the last thing we are going to be looking at is the quotient property of radicals. And that says the square root of a quotient equals the quotient of the square roots of the numerator and the denominator. Sorry again. So, in other words, if I have the square root of 16 over 25, that is simply the same as the square root of 16 over the square root of 25. So the main thing about the rule, and if you remember, we do not want to leave any square roots in our denominator. We would have to rationalize that. We're not going to deal with that today, but that is something we will have to worry about at some point. So the quotient property states that the square root of 13 over 100, well, if we look at that, I don't know of any number of times itself that would give me 13 hundredths. Good news is I can rewrite this as the square root of 13 over the square root of 100. Well, I can't take the square root of 13, so that stays as the square root of 13. But I can take the square root of 100, and that would be 10. And that's my answer right there. That's all I have to do for those. Put the square root in the numerator and the denominator. Take the square root of what you can, and what you can't, leave it. So the square root of 7x squared is the same as the square root of 7 over the square root of x squared. I can't take the square root of 7, so I leave it. I can take the square root of x squared, so that's x. So I can take the square root of that. Okay, square root of 449 is the same as the square root of 4 over the square root of 49. The good thing is both of these are perfect squares, so I can take the square root of both of those. So I'd be left with 2 sevenths. Okay, last slide for this lesson. This would be the same as the square root of 7 over the square root of 81. I can't take the square root of 7, so I'm going to leave that as the square root of 7. And I can take the square root of 81 because it's a perfect square, so it'd be the square root of 7 over 9. This one, a little more complicated. I'm going to write it as the square root of a to the third all over the square root of 121 m to the fourth. For this one, I would have to rewrite it first because a to the third is not a perfect square, but I can make it into a partial perfect square by writing a to the second times a all over the square root of 121 times m to the fourth. Find my perfect squares, and there they are. So let's look at what we would be left with. The square root of a squared would be a. I'd leave the square root of a in my numerator because I can't take the square root of just an a. Square root of 11, or square root of 121 is 11, and the square root of m to the fourth would be m squared. Okay, and last example right here, same as the square root of 100 over the square root of 4x squared. I can take the square root of 100, I can take the square root of 4, and I can take the square root of x squared. Square root of 100 would be 10, the square root of 4 would be 2, and the square root of x squared would be x. All right, there you guys go. Please look over these notes. I'll send these notes to you guys as well. On top of that, please email me if you have any questions or contact me on Canvas or join our weekly Zoom on Thursday. I'd love to see more of you guys in there, especially if you have questions. But please, please, please rewatch these videos, look over them, do your work, and send that work to me as soon as possible. Have a great week, guys.